show a couple of key places around like where some of this stuff like interacts. So kind of hopefully everyone gets a good idea of kind of how all the different components are interacting. Because the command that we're going to add today, which is going to be clearEnV, is actually already implemented. You can do it on the Windows Meterpreter, but you can't do it on the Python Meterpreter because it just simply doesn't exist. But we're gonna fix that today. So first of all, I also have Metasploit framework loaded up in here. It should be like the latest and greatest. I think I did a git pull maybe like yesterday or something. But my branch is on the main branch. I'm pretty confident. Yeah, I'm on a pretty darn recent version. It looks like it was like brand new. But so first of all, let's go ahead and do like the before and after here. So I'm using the Python Meterpreter payload over here. So I'm just gonna do I'm gonna do a generate-f, do it to make it raw. And I'm just gonna go ahead, I'm gonna copy and paste this, show options, make sure everything's correct here. Yeah, that's all good. So we're starting my handler. Now down here in this bottom left corner, hope everyone can see this. I bumped up the size a little bit. I'm SSH'd into a Windows Server 2019 instance. It's one of the main targets I typically do a lot of my development on. And yesterday I installed multiple versions of Python on the systems. I have a pretty good variety. The Python Meterpreter, if you actually do like a show info on it, it should be compatible with Python 2.5 through 2.7 and then 3.1 plus. So it's important that we like test out some of these versions. So I kind of try to get a good variety. Before I go ahead and PR this work, or maybe afterwards, I'd like to show the PR process. I'll probably try to test it on Python 3.1 to make sure. So it's working on 2.5, 2.7, 3.1, and like 3.9. Like that's pretty good. It's highly unlikely that if it works on those 4 versions, it's going to be broken on like 2.6 or like 3.5, like one of the middle ones. If we're doing like major features, I'll oftentimes like test all the versions, but I don't really think that's necessary for today. So anyways, we're just going to use Python 3.5 today. So we'll run -c, we'll go ahead and throw in our stager there, and we have our Meterpreter sessions -i -1. Sweet. Okay, so we're gonna do help, and if you're super familiar with Meterpreter, this clearEnV command, this clearEnV, that's not going to work because we don't have the commands implemented for us. This is what we're going to go ahead and try to get to work today. I checked it out yesterday to make sure that it would work in the Windows Meterpreter. I'm actually already seeing something that's a little surprising here. So the Meterpreter commands are implemented by these Ruby functions over here. So we're gonna look through the Ruby code. So this is what actually gets executed when you run the clearEnV command. Help clearEnV. Trying to make sure this is the right command. I'm thinking it is. Yeah. So clearing the event log. This is gonna be the one that we're gonna go ahead and take a look at. Yeah, so this is what actually goes in. So it's going to name out, the application, system, security logs. It's going to append anything additional that the user specified. It's going to flatten it, and then through each one of those, it is going to open it. Oh, okay, I think that's what's going to happen. It's going to complain that the length can't actually be executed, and then it's going to go ahead and clear it on out. So that might be a problem. I was not anticipating that, but that is the joy of live streaming. We will do it live, and we will figure that problem out later. That was not part of my game plan that I will show. But anyway, so the different Meterpreter commands, so that's like the UI command, right? That's like what you punch into the Meterpreter UI. But what we got down here is, or not down here, we've got actually up here is the list of command IDs. So these are the Meterpreter commands, like the low-level commands that are necessary to provide this particular UI command. So clearEnV is registered as saying it needs to have event log open and event log clear, but it looks like it's actually missing close as well as the one to get the number. So we'll see about that. But anyways, so with these commands missing, this is basically what allows Metasploit to know that this command is not going to be supported by the current Meterpreter. So if you loaded up Windows Meterpreter, as part of the Meterpreter loading, the Meterpreter is going to tell Metasploit, I support these like 200 commands, and Metasploit's going to be like, okay, so if you support the sysconfig drop token command, then I should know that the drop token UI command is available for users. That's how that functionality works. And we're just going to be working at the Meterpreter prompt today for the UI, but these are also utilized by like post module. So a post module can say I need these 10 different Meterpreter commands because of the functionality that it uses or whatever. And the Metasploit will use that information to tell the user like, hey, like you're trying to run this post module, but it's probably not actually compatible with this particular session because we have a bunch of different Meterpreter types. You just can't do everything on every different Meterpreter. Like a really good example is like the Kiwi extension is like super popular. That's exclusive to the Windows Meterpreter. Like we don't have that for Java or anything like that. But today we're going to really focus in on the Python Meterpreter. So before I go ahead, one last thing I probably should mention before I really got started, this sys file. You're probably wondering like, what is this file? This file is in librex post Meterpreter UI console and then command dispatcher, which are going to be where all the Meterpreter command dispatchers are located. So for the sys group of standard API extensions, like this is where all those commands are implemented. So because we know clearEnV isn't working right now on the Python Meterpreter because it's just not implemented, we know the commands that we need to go ahead and look at. So that's kind of the Ruby background here. I'm trying to keep an eye on questions in the stream. So if anyone has anything, just feel free to shout it out. I'll try to keep an eye on that. So I mentioned the game plan. I looked into this yesterday to try to hopefully make sure that everything would go smoothly today. We'll have minor hiccup, but that keeps things interesting. We'll roll with the punches as it goes. But anyway, so we know we need to add in these three at least. I'm suspecting there's that fourth one. But each of these command IDs is a pretty thin wrapper around a Windows API call that we will utilize Python C types to go ahead and invoke. It's a pretty popular pattern that Meterpreter or the Python Meterpreter specifically uses for a lot of these. So it's a little bit specific to the Python Meterpreter, but a lot of the core concepts that we're talking about are the same across all the Meterpreters. Like all the Meterpreters specify these command numeric IDs ever since like version 6. We dropped all the strings in favor of these numbers and allowed them to be enumerated. Different depending on the version of Meterpreter, but let's go ahead and like really dive into the code here. So I'm going to, of course, use git once my computer starts working here. I have the repository cloned already. I'm going to use the Metasploit payloads because that's where the Python Meterpreter source is. The Metasploit payload repo has the Windows Meterpreter, the Python Meterpreter, Java, and PHP. The only one that's not in Metasploit payloads is in the Metal repo. So since I'm doing a Python, this is the correct one. I'm just gonna make sure everything is up to date beforehand before I really get started. So I am PRing off of a up-to-date branch. Want to avoid conflicts at all costs. Like illness, an ounce of prevention is worth a pound of cure when it comes to conflicts. Okay, check out -b, we'll call this feet. What's the naming convention that I use? Feet, met pi something, pi / event logs. That's a pretty good name. Okay, cool. So the Python Meterpreter is actually provided by these two files right here. So the first thing I'm going to do is I'm going to need to test this code. Being that we're only working in the standard API today, I need to have a way to load this. So what I'm going to do is I'm going to do a symbolic link -s. Was it like pwd? Okay, so I'm going to target link name .msf4 payloads Meterpreter. All right, so what I just did was I created a symbolic link for the actual binary Meterpreter binary file I wanted to load, and I'm having a hard time typing and talking here at the same time. And I linked it into this directory right here. So everyone should, if you have like Metasploit and you've ever run it before, you should have the .msf4 directory. That's like your user config data. You probably don't have the payloads and the Meterpreter subdirectory in it though, but if you make those directories, then Metasploit will load the payload data from that directory instead of the gem, which is like what Rapid7 ships. So this is like one of the easiest ways to test your Meterpreter changes locally. So now that I have that set up here, I can go ahead and I can make my changes to this file without moving it out of the Git repo, and then just like restart my Meterpreter session every single time. It should be a little bit better. We should actually get a warning message if we run this again. So we just exited out of that session. Jobs, our handler is still listening. We're just going to restart the Meterpreter. And we get this warning right here saying that the local file is being used. That's great. I want to see that warning because that's showing that it's loading the code that I am providing that I'm going to start editing. So everything is all set up here. So now that we know that we are loading that file, let's go ahead and actually edit it. So I mentioned before I was using RubyMine, but RubyMine is like a Ruby IDE. For the actual Python code itself, I'm going to use Genie. I mean, you can use whatever text editor you want, if you want to use Vim or whatever. I really like Genie, so I know a lot of people are really interested in like specific tools. I've used Genie for years now. The extension has to be a single file in order to get loaded up, so it is quite a large file. It's pretty well organized, but yeah, it's a very large file. We can't, for the Python Meterpreter, we can't import any third-party libraries because there's no guarantee that the remote system that you're compromising is going to have those available to it. So it does make development a little bit tricky, but that won't be a problem for us. We will work straight up beyond that. So I looked into what we would need to do for the game plan. It's probably worth noting how I came up with this information. So I know that from looking at that Ruby code, we need to do standard API assist event log open. It's going to be one of the very first commands that we need to do. In the Python Meterpreter, the individual commands are listed down here. You just name the function the same as the command, lowercase, and then use this decorator to register that function. And then the Meterpreter core will call it with the request and response object that you'll use, and that's just how you register the commands. So let's try to keep them in alphabetical order, and we'll do the very first one here, event log open. It's going to be the first one that needs to get executed. And then we'll start looking at the actual implementation here. That was sys, right? Sys event log open QRS log clear and close. Interesting. Okay, yes, that's why some of these are actually already here. Okay, so that's why the command is actually showing up. Well. Okay, so what we're going to do is, so we have our event log open, which is right on down here. We are going to fix that error. We are going to jump straight into fixing that error that we were getting. So when we try to go back over here, -i2, help. So we see that the clearEnV was actually registered already. And that explains that because those commands are present. But when we actually try to go ahead and clearEnV, it's going to fail because this particular command is not present. Right, event log num records, saying that the handle is invalid. We do actually have this. Huh. All right, I apologize. It looks like we actually have everything is already done. I don't know why when I was looking through the Meterpreter yesterday, I thought none of this was implemented. Okay, I am thinking. All right, we are going to pivot entirely and we're going to throw out that game plan. We're going to go back to plan B. Goodbye, game plan. Okay, new game plan. So since clearEnV is actually implemented, there's something going on with why it's complaining that the handle is invalid. I'll fix that later on because that's an unrelated problem. That is not related to the fact that it is not like straight up implemented. What is also not implemented is the process attach API. So we're gonna focus on that one instead because now we'll be able to actually add in like a brand new implementation. So Meterpreter handles processes, and you can like open up the object and then like interact with it. So if you like run a command or something like that, you are spawning a new process. But you can also attach to existing processes, which is what we are going to lay the groundwork to go ahead and actually implement. Because we don't have the ability to open a handle to an existing process. I can see that down here because process attach is not implemented. So that'd be a little bit more tricky to, debug, but I have an idea in mind for that anyway, so that'll be okay. We're flexible. Okay, so switching back over, the new game plan is going to implement in process. You can go ahead and look at attach. Okay, so you want to go ahead and, okay, so when we're opening, it's going to come down here into open. Okay, this is the command that we're going to go ahead and implement. And for realsies, this time it's actually not present. Sysprocess get, sysprocess attach would be right up here, and it is not here. Okay, so yeah, we are going to implement this one. Okay, so we're going to hit register function, drop that on down into here, and we know that we're going to name it all lowercase because the naming convention is really important. So standard std API sysprocess attach sys attach, and we always accept the request and the response object. Request. I promise I can type these words. Return error, success, and response. Okay, cool. So we are going to register the function, and it currently doesn't do anything yet. So we know this is our goal. We want to be able to attach to existing processes, basically like by using the debugging API. Now, we need to know, what is that function supposed to do? Well, one of the best ways to actually like go ahead and figure this out is by going right on over to a Meterpreter that actually already implements this. The Windows Meterpreter has some of the best command coverage. So if you're looking for like any of the Meterpreter commands, the Windows Meterpreter has it. It's implemented in C, and it's what people commonly refer to when they're talking to you about just, Meterpreter in general. They're almost always just referring to the Windows one. It's got a whole bunch of extensions, and none of the other ones do. And the standard API has a lot more commands than the other ones do as well. So we're looking at sys process, and then somewhere in here, attach is going to be defined. Here we are. Okay, so the Windows Meterpreter uses a slightly different naming convention. It's going to be, request sys process attach, and because it's C, it registers it differently because you can't use like a Python decorator. But the result is, or the formatting is kind of pretty similar. Remote is going to be the request, if I recall correctly, and then the response is going to be for the packet, which is why you can see we're creating a response down in here. So what this is pretty much doing, this is the entire handler for sysprocess attach. And what we're doing is we're just going to call open process, and we're taking the parameters for open process from the TLVs that are coming in from the request. So we need to look at what parameters are coming into the function. So that's going to be like what parameters Metasploit is sending to it. You can think of those as like the function arguments. So we can see we're taking the process ID, whether or not to inherit, and the permissions. And we can see it's 2 unsigned integers, a Boolean, and that is all of the parameters. And what we are expected to return is going to be a keyword, which is going to be the handle, which is the straight up value from open process return. So pretty straightforward. We just need to be able to utilize C types to go ahead and invoke open process. So without further ado, let's go ahead and take a look at that. I had to throw out my game plan, so we're going to switch right on over to MSDN to do this live. We're going to pull this up. This function is pretty familiar, or a lot of people are familiar with this if you've done any kind of process hacking. So we have our prototype down into here, and we know that the DLL that it's coming from is kernel 32 DLL from looking at the docs here. All right, so let's expand this on out. I'm gonna, where am I? Scroll, here we are. I'm gonna drop that down here into my notes. So remember that's what's taken, and this is going to be from kernel 32. I don't think I'll forget that, but just in case. So we need to be able to get those parameters out. So before we can extract the 3 parameters that we need out, we need to know whether or not they are defined. So let's pull this up over here in the split window, and let's see if TLV type PID is already defined. Sorry, I've got a split screen here, so we got to switch that back over here so everyone can see the same thing. Okay, so TLV type PID is already defined. Wonderful. Next up, it's going to be TLV type inherit. It's going to be a Boolean. I don't know if this one's going to be defined or not. This one is also defined. Wonderful. Go us. Okay, type process perms. I'm hoping there will be at least one I can actually define so I can talk through how you define these. Process perms. Okay, that one is also defined. Okay, the handles can be our last hope for one that actually needs to be defined. But I really think TLV type handles can be defined already because that one's used quite a few different places. Yes, that one is already defined. Okay, so in this case, all the types are already defined. Let's say the TLV type handle wasn't defined, though. We'll just cut this line right on out. So what we would do, basically, is we would use this. So what we're seeing popped up right here is a source graph. Super handy extension. I'm just going to go to the definition right here, and it's going to tell me the Boolean flags that are basically defining this type. So we can see that it is a keyword, and starts with the standard API extension base, which happens to be 0, and then the actual value is 600. So we would come down into here, and we would pull that information out, and I'm actually just going to undo my deletion, and that's where we get that information. So that's saying that this TLV type, the underlying data type, the meta type, is a keyword, so it's gonna be like a 64-bit value, and then its unique identifier is 600. So when you have like Meterpreter functions, you can pass in like one handle, but if you need like an input handle and an output handle, you would most likely need to give each one of them an individual ID, which you can actually like see right here. So some might need to have like a process handle and a thread handle. Otherwise, if you need to accept like multiple handles, you would have to get into like weird things where the ordering is like important and stuff like that. So it starts to get a little bit more complicated. But because each one of the types only appears once in the function, it's all right. And what I mean by that is we're only accepting one. Let's see, where was I? I was talking in circles here. We're only accepting one PID. We're only accepting one instance of whether or not we should inherit, and we're only accepting. That's cool. Source graph. I'm good. Escape. Nope. Have to refresh this page. We're only accepting one of each of those, so they're uniquely identified well enough, and we can go ahead and pull these out. So yes, we know we need to call open process, and we're going to return that PID back on over. So let's see. Okay, so the way we actually pull this information out, I'm just going to try to go ahead and port it here. So first up, we're going to try to pull the PID out. It's going to be TLV type PID. So we're going to do PID equals packet get TLV request. TLV type PID. This packet get TLV function is actually defined over in the core Meterpreter and through like Python magic. It's exposed basically globally, so you don't have to like import it or anything like that. Just going to pull that up here so we can take a look and see what other helper functions are available in there. All right. Yeah. So this is the core Meterpreter, and we have there you go. Like packet get TLV. The ones that use this the core functions that use this export decorator are basically like global functions that any extension can use. I say any extension, but the Python Meterpreter only has the standard API extension. But that's where that comes from, because you won't find it defined in here, and you'll also notice that it's not marked in the imports. So that's where that's coming from. Where was I? Okay. Again, I promise I can spell. Cool. Okay, yeah, so we're pulling out that PID right there. I think Yep. And so packet get TLV is actually going to return a hash. So we actually want to pull out the value. So we'll extract that value there. And then if PID is 0, we want to be able to go ahead and use the current process ID. So if not PID equals os.get PID. So we'll do it that way. Easy enough. And so here's like a little point of discrimination, I guess, actually. So it looks like the inherent and process. Really wish I could make this a little bit smaller here. Can I zoom out? Can't seem to get all of this in. So whether or not you want to inherit or the process permissions are ignored unless the PID is specified. So that's odd, but we will replicate that behavior to try to do the exact same thing the Windows one is doing. So that way we don't introduce an additional inconsistency in the behavior. So now we're going to go ahead and we're going to do inherit equals packet get TLV requests. You'll notice I'm not really using error handling super liberally. There's a global, or not a global, but basically when this function is like dynamically invoked, it's in exception handling already. So if something happens in here, like one of these parameters aren't present or something like that, it'll get logged as appropriate and everything. And we'll probably see that because I doubt I'll get everything right on the very first try. Maybe I will. We'll see. So what was that? Process perms. Okay. And permissions. All right, and oh, I misread that actually. We're not specifying the PID. We are straight up pulling out the handle. Let's see, get current process. I want to say the handle is actually always -1. So we'll go ahead and specify that. That'll be something interesting to test because I think when that gets converted over to a keyword, that'll need to be, was it like all Fs? So here we are, and now I believe it is time to actually go ahead and invoke the function. So for the ctypes function, let's see if I'm sure we can find an example here. 2.dll, whoops, not .dll, dot something, anything. Here we are. Okay, so expand environment strings A. So we have this one right here. Oh, this actually straight up invokes get current process. That is probably a better idea than what I was previously doing. Let's do that. Okay, so this is what I was kind of looking for. So in this one right here, we are updating the function prototype to specify the arguments and the return type. You have to do that sometimes with Python, particularly on 64-bit Python, because the way ctypes works is basically all the parameters are treated as like 32-bit. So handles and 64-bit values and other things like that, it'll start to get really tricky and get really weird errors because they'll be truncated without you realizing it. So we're going to do that just to be on the safe side. All right, process attach. We're going to update this to be even better. Yeah, straight up, just like that. And where were we just now? Yeah, okay, so let's pull this on out, and we're going to come right on down here. Okay. We're not doing format message, though. We are doing open process. And that's why I copied this earlier, so that way I'd have this information right here. Yeah, so we're doing kernel 32, open process, and our argument type. dwords are always going to be 32-bit. It actually does look like in this one that the 64-bit arguments aren't going to matter. It's just going to be the return type that we would actually need. It's no problem in being super explicit, so let's go ahead and just do that. Anyways, ctype C bool. You'll notice I'm not using win types. That's because we don't actually use win types in here, because while we're developing a function that we think for today is only going to work on Windows, if you do reference win types, you have to use all of these guards to ensure that when the Python interpreter is loaded on Linux or OS X or a system that doesn't have win types, that it is not going to crash. Which is what I am looking at in through here. Sorry, I just noticed something. Okay, pull that up in there from master. Okay, yeah. Let's, okay, so D word is always 32 bits, you type bool. The other one's gonna be a D word. And then handle is going to be void P. Void P, just like that. Now, of course, that is misdefined, so we'll go ahead and do that. And then here we are, I'm going to do handle equals open process, and now we are going to forward the argument that we extracted from the TLVs, and that is going to be, okay, so permissions, inherit, and PID. I'm glad I had this down here because I thought the PID would have been the first one, so that's handy dandy. Okay, so now at this point, whether this is invoked or not, we will have the handle. Let's go back over here and look at the Windows interpreter one. Okay, so if the handle is false, it's probably gonna be if it's 0. I'm betting that's what the return value is, right? Yeah, okay, so it's gonna be null on failures, it's gonna be 0. And then we'll fail out with a Windows exception, which will be a problem. Not a huge problem though. Okay, yeah, so if handle, we return that back into there. Otherwise, we have get last error. So we handle that slightly differently in the Python Meterpreter. So this is actually kind of the better shorthand way to do it. So we'll come on down here. If not handle, so if it was null, we will return the error result from Windows. I actually just realized this was a mistake. We don't want to register this function for everything. We only want to register this function if has WinDLL, because we know this function is not going to work on Linux because Linux doesn't have kernel 32. So we're only focusing on the Windows implementation of this for right now. We'll save Linux OS X for another day because you'd have to use like the ptrace APIs and stuff like that. It's completely different. So we'll just keep it in here. And then eventually when sysprocess attach has all of like the support, you'll probably see it looking something like, we have a few of them in here. Basically the core function will like dispatch to it. Here we are, get processes. So get processes has to function completely differently depending on the platform. So you know, if you have /proc, it's assumed that you're like a Linux system and it'll pull the processes from there. If you have WinDLL is available, it's assumed that you're on Windows and you can use ctypes WinDLL to like use that process API. Otherwise, it's just going to invoke like the PS command, which would be if you're on like OS X or some other Linuxy system where you have a PS binary, but you don't have the /proc file system. But we're only doing it for Windows right now, so we'll just make sure that the function is only registered for Windows because it'll never work on Linux or OS X. So by not registering it, again, when Meterpreter connects back up into Metasploit, it will not show up as being available. And I think this is almost all that we need. So last thing we've got to do is we've got to return the actual response. I am totally just copy and pasting. And that is going to be a TLV type handle, and we're going to return the value of the handle. And there we are. That should be it. This should work. TM. Okay, so we're going to restart our Meterpreter. We only need to restart the Meterpreter code, so we're not going to restart Metasploit altogether. So let's go ahead and run in through here. Okay, so we have a brand new Meterpreter session now. We're just going to interact with the latest one. We are running a Python Meterpreter. And let's see, get UID. I am running UID. I'm running a Spencer McIntyre, so I should be able to open a handle to another process. I'm just going to try to pick one down in through here. I'm going to open a notepad to invoke it. So yeah, since we're not using Event Viewer, we had to pivot. Go ahead and pop up Notepad. Okay, so we're going to pick on Notepad. And the way that we're going to validate that everything is working correctly, because we're working on this in a very small incremental fashion, is we are going to pull up Process Hacker, which allows us to view the handles. All right, here's Process Hacker, 64-bit. Run this as an administrator. We're basically going to use process hacker to inspect the Python process. Python process, get PID, it's going to be 5876. Cool. All right, let's take a look at this one. And here we are, handles. Perfect. So that's the actual handle value, handle type. Okay, so we have no process handles in here. I'm pretty darn sure that when we open process, one is going to show up in here as a process, and it'll show up to Notepad. And that's how we're going to validate that this is working, because it can return that value back to us. And we should actually be able to see the value and validate it against process hacker. So, all right. So I know where I'm looking at, have Notepad, we're going to pick on Notepad. Everybody likes picking on poor Notepad, so that's going to be 3784. And my apologies, I thought we were going to use clearEnV, where we would have had like a nice UI command wrapped around it, but this time we are going to invoke the lower level APIs to make sure that everything is going correctly. So we're going to invoke this code that we're looking at just like right here. So we're going to call process open, we're going to hand it that PID, and it's going to try to open that process with all access. And if everything goes successfully, we should see the process handle show up in here, and it should be the correct value, and it should be into Notepad. That is the game plan. So we don't necessarily have a nice wrapper around the command, because we're trying to invoke something very specific. Let's post. See if we can copy and paste this here, actually. Nope, we cannot. Post Meterpreter extensions. This process. Okay, cool. That is our class. And now we are going to do open. I already forgot it. I think it was 3784. Is that right? 37. Yeah, 3784. 3784 is going to be our PID process handle. And now you can't see, but I'm crossing my fingers. Hopefully this works. And it did not. Okay, undefined method send request. Self. This. I forgot the way this is actually implemented. You actually have to do it